Hello, everyone. Get ready to unlock some amazing secrets of the universe. Today, we're going on a thrilling journey to meet a true genius. He figured out how planets move, even before we had super powerful telescopes. This is mind blowing stuff, and it's going to make you see the stars in a whole new way. You're about to learn something truly powerful and exciting that shaped our understanding of everything. Let's dive into the fascinating world of Johannes Kepler. Johannes Kepler was born a long time ago in 1571 in a country called Germany. Imagine a time without internet, without even basic electricity. That's when Kepler lived. He was a smart kid, even though his family wasn't rich. Sadly, he got sick with smallpox when he was young, and it even affected his eyesight. This made things a bit harder for him, but it didn't stop his brilliant mind. Kepler went to a university called Tübingen. He studied many things there, like religion, philosophy, and of course astronomy. Astronomy is the study of stars and planets. He actually wanted to become a priest, but because of some religious problems at the time, he couldn't, so he became a math teacher in a place called Graz. This was a super important step in his life. Now, here's where things get really exciting. In 1600, Kepler met a very famous astronomer named Tycho Brahe. Brahe had spent many years carefully watching the planets and stars. He had tons of data which are like super detailed records of where everything was in the sky. This data was incredibly valuable, like a treasure map to the universe. Kepler became Brahe's assistant. Imagine working with the best in the world. But there was a small problem. Brahe was a bit secretive and didn't share all his precious data with Kepler right away. He wanted to keep some things to himself. However, fate had other plans. Sadly, Tycho Brahe passed away in 1601. After Brahe's death, Kepler finally got access to all of Brahe's amazing astronomical data. This was a game changer. Kepler spent years and years studying this data, especially the movements of Mars. Mars was a tricky planet to understand, and its orbit didn't seem to fit the old ideas. Kepler worked tirelessly, making calculations again and again. He was like a detective looking for clues in the numbers. And then he had a breakthrough. In 1609, he published a very important book called Astronomia Nova, which means New Astronomy. In this book, he shared his first two laws of planetary motion. These laws completely changed how people thought about the universe. His first law, the law of orbits, states that all planets move around the sun in elliptical orbits. An elliptical orbit means it's not a perfect circle, but more like a squashed circle, an oval shape. And the sun is not exactly at the center. It's at one of the foci of the ellipse. A focus is like a special point inside the ellipse. This was a huge discovery, because people used to think planets moved in perfect circles. His second law, the law of areas, says that a line connecting a planet to the sun sweeps out equal areas in equal times. This sounds a bit complicated, but it just means that when a planet is closer to the sun, it moves faster, and when it's farther away, it moves slower. Think of it like this: if you draw a line from the sun to a planet, and then watch that line as the planet moves, the area that line covers in, say, 1 month, will always be the same, no matter where the planet is in its orbit. So, equal areas means the same amount of space covered, and equal times means it takes the same amount of time. This explained why planets seem to speed up and slow down at different parts of their journey. Kepler didn't stop there. He continued his work, always searching for more answers. In 1619, he published another important book called Harmonices Mundi, which means Harmonies of the World. In this book, he presented his third law of planetary motion. This one is called the law of periods. His third law, the law of periods, connects the size of a planet's orbit to how long it takes to go around the sun. It says that the square of a planet's orbital period is proportional to the cube of its semi-major axis. Don't worry too much about the big words. Orbital period is simply how long it takes for a planet to make one full trip around the sun. And semi-major axis is half of the longest diameter of the elliptical orbit, basically. It tells you how big the orbit is. What this law really means is that planets that are farther away from the Sun take much longer to complete one orbit. For example, Jupiter is much farther from the Sun than Earth, so it takes much longer than one Earth year to go around the Sun. This law showed a beautiful mathematical relationship between all the planets in our solar system. Kepler's work was revolutionary. He didn't just stop at observing, he used math to explain what he saw. He even improved the refracting telescope, which is a type of telescope that uses lenses to make things look closer. He also did important work in the study of light, which is called optics. He laid down many of the basic ideas for how light works. He also wrote a book called Epitome Astronomiae Copernicanae, which supported the idea that the Sun is at the center of our solar system, not the Earth. This idea is called the heliocentric model, and it was first suggested by another great astronomer, Copernicus. Kepler was a strong believer in this idea and helped to spread it. Kepler's life was full of challenges, including religious conflicts and personal losses, but his dedication to science never wavered. He passed away in 1630. His laws of planetary motion were incredibly important for future scientists like Isaac Newton, who later developed the law of universal gravitation. Newton used Kepler's laws to help him understand why planets move the way they do. So, Johannes Kepler was not just an astronomer, he was a natural philosopher, a mathematician, and a very deep thinker. He is often called one of the fathers of modern astronomy, and a key figure in the scientific revolution. The scientific revolution was a time when people started to use observation and experiments to understand the world rather than just old beliefs. Kepler truly changed the way we look at the sky and our place in the universe. His legacy lives on every time we send a probe to another planet or predict an eclipse. What an amazing person.